This last clip will be about balancing chemical reactions. And it will be based on the fact that as long as there's no nuclear reaction, Dalton's law tells us atoms are neither created nor destroyed in the chemical reaction. And therefore, in the chemical reaction, we have to have the same numbers of each of the elements on both sides. And I'm going to teach you a general procedure that works pretty much in all cases. And we're only going to improve upon it at the end of the course for reactions that take place in water that involve the exchange of electrons, which are called redox reactions. We're only going to do that at the end. This is going to be the go-to method for this course. And you're going to want to pay attention because these problems can actually get tricky. Okay, so let's first look at this reaction here. S2Cl2 plus NH3 going to S4N4 plus NH4Cl plus S8. And as you can see in this reaction, as written, there are 2 sulfurs on the left side and 12 sulfurs on the right. This is called an unbalanced reaction. Unbalanced because we do not have the same number of atoms on both sides. That word that's hard to read is unbalanced. And the procedure that we're going to use is the following. We're going to identify the compound with the most elements. And if there's several with the most equal number of the most elements, you can choose either one. In this case, the compound with the most elements is NH4Cl. It has 3 elements. And we've decided in this class to put the number 6. And many of you have a question, why the heck 6? And actually, it has to do with a lot of the math skills of 2070 students. Many of you make mistakes, algebraic mistakes with fractions. And if we use a 6, that's going to cut way down on the number of fractions. Okay. So we're just trying to help with this strange number. And now we look for the element that only appears once more. So you can see that N appears 3 times, once on the left, twice on the right. But I didn't ask how many times the element appears. I asked you how many times it appears once more. In this case, there are 2 compounds which have an N that have no coefficient, so N appears twice more. And we're looking for an element that appears just once more. Can you put in chat what those elements are? Put it in chat. Yeah, just put it in chat. There are 2 of them. The 2 elements that appear once more, as many of you have it, are are H and Cl. H and Cl. So let's just do this Cl. There are 6 Cl's on the right, and this is S2Cl2, so the coefficient here is 3. And that puts equal number of Cl's on both sides. And then the next element was H. There are 24 H's on the right. That's 6 times 4. And therefore the coefficient here is 8. And now we have 2 more elements, 2 more compounds, S4N4 and S8. Which element appears only once more? Well, S appears twice more, those in both compounds, so it's N. We've got 8 N's on the left and 6 N's on the right. We need 2 more, which means that the coefficient here is a fraction, our first fraction, 1/2. And that puts 8 N's on the right. And finally, we can do sulfur. There are 6 sulfurs on the left, plus 2 sulfurs from this 1/2 S4N4. We need 4 more sulfurs, which is another 1/2. So that's a balanced chemical reaction, but not in its ordinary form. In its ordinary form, which is we'll require in this course, the coefficients are all whole numbers which do not share any common factors. Whole numbers which do not share any common factors. And so in this problem, what we're going to have to do, since we have a 1/2 in the denominator, is that we're going to have to multiply all the coefficients by 2. So it's going to be 6S2Cl2 plus 16 NH3s. Go to 1/2 times 2 is just 1 S4N4. When the coefficient is 1, we don't even bother to write it. Plus 12 NH4Cls plus just a single S8. And that's the balanced chemical reaction. In any ordinary world, the technique I just told you will always work. There's only one place that I know where this technique can fail. And that is in Gen Chem exams and Gen Chem problem sets. And but we can just adapt this method with one thing and it'll work there. And I'm going to teach you this one adaptation, which you really should learn. And by the way, it's much better than the technique in the textbook. It's much faster. So here's the example. It's just a souped up version, an algebraic version. And algebra and its connection to chemistry is a big theme in this course. HNO3 is nitric acid, and here's another unbalanced reaction which we're about to balance. So, what are we looking for now? We're looking for the compound with the most elements. Put that in the in chat. Which of these compounds has the most elements? There's one compound with 4 elements. You writing it? Yeah, it's AgNH3 2Cl. And what's the coefficient we write in front? It's a 6. So you can reduce your fraction overload. And now there's only Ag only appears once more. Cl appears only once more. So it's a 6 over here. And now we encounter the problem. The element H appears twice more. How many more times does N appear? If you wrote 3, you're not counting quite right. All we need to know is the number of compounds where N appears. The fact that N appears twice in one compound doesn't matter. So N appears twice more. And so we don't have an element that appears once more. We need to invoke algebra. And this is the trick. We're going to introduce a variable x. In the spirit of reducing your fractions, we're going to introduce a variable 6x. And just like before, we're going to put it in front of the compound with the most elements. Well, they both have the most elements. I'll just put the more complicated one, NH4NO3, and I'll put a 6x in front of it. And now I can balance for an element that appears once more, and you should just pick the easiest element. And to my eyes, the easiest element to pick is O, because it only appears twice. There are how many O's on the right side? Include the X. How many O's? Put it in chat. How many O's on the right side? That's right. There are 18x. So the coefficient here is 6x. So that we have the same number of O's on both sides. And now we must solve for x. And what you need to do is pick an element that we haven't balanced for. And pick the easiest element. To my eyes, it's N. So, maybe no, H. H is easier. So we've got 6 times 6. We have 36 H's over here. NH3 twice times 6 plus 6x for this HNO3. And on the right side, we have 24x. And so we get that 36 equals 18x. And x is equal to 2. And I'll just put the new values up here. X is 2, so this is 12. And this one is 12. This one doesn't change. It's 6 because there's no 6. So these are in circles. And now, remember what I said, that we need to get rid of all common factors. What's the common factor of 6, 12, 12, and 6? The common factor is 6. So we get rid of that, and we're going to get AgNH3 2Cl plus 2. Remember, we're taking it for all of them together. Goes to 2NH4NO3 plus AgCl. And you really want to get this second method down, as useless as it is outside Chem 2070, because it is a general feature of Gen Chem courses that we all throughout the nation test on your ability to use, even when necessary, algebra.